Thank you for joining Scientific Environmental Instruments Incorporated for this video. The video that follows depict a combined cycle power plant and a duct burner optimization plan. Our acoustic pyrometer will provide a two-dimensional thermal map upstream of a HRSG. The cyclic manner of combustion caused by duct burners causes stress on the superheater tubes. Damage is caused internally and externally. Our boiler watch MMP2 acoustic pyrometer will provide a thermal map that will allow the plant operators to prevent flame impingement on superheater tubes. It will allow for early detection of malfunctioning duct burners. Boiler watch MMP2 is a very fast detection of anomalies that affect the combined cycle power plant. The acoustic pyrometer, when installed in a combined cycle power plant, shows much information on the gas temperatures of combustion from the duct burners upstream of the superheater tubes. Increasing heat flux to the HRSG allows for more output to the steam generator, which increases the megawatts of the combined cycle power plant. Scientific Environmental Instruments Incorporated suggests that when our acoustic pyrometer is installed, that the plant operators make duct burner tests to determine which areas of the thermal map allows increasing the heat distribution by manual valve adjustments to specific runners. Depending on the results, Scientific Environmental Instruments Incorporated believes that a totally automated system that uses the acoustic pyrometer to fine-tune the gas pressures will assure the highest efficiency, while maintaining temperatures below the metallurgical limits of the pressure parts. The image below is a publication in Power magazine created by Mr. Douglas Hilleman from Intertech, and the publisher, Mr. Aaron Larson, for the month of July 2018. Note below, on the left image, flame impingement. Below, a graph that shows over temperatures caused by the flame impingement. Currently, many combined cycle power plants are required to change load frequently, creating severe metallurgical stress that are causing issues on terms of availability, from the most prevalent cause, steam leaks. The cycling introduced the duct burner, a valuable tool that uses the exhaust turbine excess air with added gaseous fuel to augment energy to the HRSG. Duct burners have allowed for power generation increases and cycling, but at a severe cost in reliability from the lack of supervisory information. Boiler Watch MMP2 supplies additional information that had not been seen in recent years. Recent installation in the USA has resulted in numerous reports for the optimization of the combined cycle power plant in areas such as fuel use, ramp-up rates, runner verification, etc. Operating efficiencies could be increased by 3% to 7%. Scientific Environmental Instruments Incorporated, our acoustic pyrometer, Boiler Watch MMP2, provides gas temperature measurement in real time. It shows a two-dimensional map. The map uses 24 trajectories of average gas temperatures with leak detection. Measurements are 4 feet upstream of the superheater tubes. With our software you can view heat flux, that allows adjustments to optimize combustion and provide a monitoring process for duct burner fault conditions. Scientific Environmental Instruments Incorporated utilizes the fundamental principle that the speed of sound in a gas change as a function of temperature. To assist in the control of fireside combustion, the Scientific Environmental Instruments Incorporated acoustic pyrometer offers a temperature array of the gas temperatures at the HRSG and continuously does two major functions. The first is creation of an isothermal map for the operator with 5 windows for viewing furnace combustion operation variables. Information of temperatures such as path temperature, mean temperature, statistics, wall temperature with alarms is available and displayed. The second is the capability to send temperature data to the plant's DCS for monitoring and control purposes. Below you can see on the left side our thermal map with isothermal lines. On the right side the 24 area, which can be any size, any location. Below, a graph that shows over temperatures caused by the flame impingement. On this page you see normal thermocouple trends with our acoustic gas temperatures. The test procedure is to adjust manually the valve, which is after the solenoid valve, and use the pressure sensor to set the gas pressure. Our software will show the changes of gas temperatures that are specific to the tested runner. Duration of test 5 minutes per runner. All gas valves open except the test runner that will be closed to specific flows. SEI Incorporated recommends closure in 25% increments. Our software will be recording all the temperatures. The software provided by Scientific Environmental Instruments Incorporated will allow quick determination on the thermal heat released by each runner. Our software offers the following windows: Isothermal map, area maps, trends of area maps, statistics, wall temperatures, alarm conditions, steam leaks. Below you can see images of our installation in rectangular combined cycle power plant and exit plane of a gas turbine. Note the locations where you can place our sensors. Once the test is concluded and the data is collected, Scientific Environmental Instruments Incorporated will prepare a report with suggestions how to operate the duct burners using the acoustic pyrometer manually. Also, a closed-loop control is possible. In order to get more definite improvements, we would require the specifications of the type of alloys in the superheater tubes in order to not exceed temperature limitation. Also, information on the total gas being used by the duct burners. We are expectant that through very precise gas temperature measurements that an increase of 3% to 7% of thermal efficiency will be achievable, since this is what Scientific Environmental Instruments Incorporated has seen in other industries.